What's going on, everybody? Welcome to another interview problem solving coding tutorial. In this tutorial we are going to do a simple task actually. We are going to rotate a matrix by 90 degrees. However, there are some initial conditions to it. And this problem is asked by Amazon, Google and Apple, I think. So it's a really cool problem and a little bit of hard actually. So they want you to rotate a matrix by 90 degrees. However, they don't want you to use any additional space. As you can see in the problem statement, it states that you need to use one additional memory. So therefore, you mustn't create any variables. Therefore, you only have to swap variables in the matrix to be able to solve this question. However, there is a little bit of trick in this question. They say that this matrix is a square matrix. So if it's a square matrix, actually there are some beautiful features of it. Since it's symmetrical, we can take transpose of it. But if you don't know what a transpose of it, I'll explain it in a minute. So this is our initial matrix, and they want the solution to be like this without creating any additional variables. So let me explain how to solve it now. A transpose of a matrix is actually pretty simple. You just take all the rows and replace it with columns. So 0th row goes to 0th column, 1th row goes to 1th column, and so on. For example, here 1, 2, 3 is now here, and 4, 5, 6 will go to here, and 7, 8, 9 will go to here. But how to take a transpose of a matrix without creating any variables? As I said before, since this is a square matrix, it's symmetrical, and we can use a simple for loop, nested two for loops to solve this question. And this for loop's initial conditions will be, so we are going to scan all the rows from 0 to n. However, we are going to scan all the columns from I to n. So why I to n? I'll explain it in a minute. So let's try to look the operations here. So in each loop, it will go like 0, 0, 0, 1, 0, 2, blah, blah, and so on. This is the whole for loop of our matrix. And in each iteration, we are going to swap variables. So we are going to swap 0, 0 with 0, 0. We are going to swap 0, 1 with 1, 0. And we are going to swap 0, 2 with 2, 0. So what happens if we do this? Let's take a look in the matrix here. So 0, 0, it will stay the same. Actually, you can start this for loop from I plus 1 if you want. It's because since the same numbers swapping will occur in the same place. So what happens if we swap 0, 1 with 1, 0? So we are going to swap these two variables, 2 and 4. So 4 comes to here and 2 comes to here. After this, we are going to swap 2, 0 with 0, 2. So we are going to swap this 3 with this 7 here. So 7 goes to here, 3 goes to here. And at the next iteration, we are going to swap 1, 2 with 2, 1. So what is 1, 2? 1, 2 is 5 here now. And what is 2, 1? Oh, I'm sorry, 1, 2 is 6 here now. So what is 2, 1? It's 8. We swap 6 with 8 here. And at the last loop, we are just going to stay in place. So as you can see from here, it will be the transpose of our matrix. So what we wanted. But remember that you can only do this swapping operation, this two nested for loops with square matrix only. It needs to be symmetrical. If it's rectangular, so if it has 3 rows and 4 columns, you need to create additional memory. Therefore, this problem is only valid for square matrices. Okay? So, what are we going to do after we take the transpose of a matrix? So if you see the transpose of a matrix, and if let's look at our solution here, it says that 7, 8, 9, 4, 5, 6, and 1, 2, 3. So if you take a closer look here, if you swap the left half of the our matrix with the right half, so swap left half columns with the right half columns. If you do this operation, you will successfully get a fully 90 degree rotated matrix. It will have two for loops again, as this one here. However, we are going to iterate through n divided by 2, which is left half of it, and we are going to subtract the size from left half and swap these variables. Alright, so let's try to write its code now. So in here, I've written the same matrix as code signal, and I have a simple rotate image function here. If you want, you can make this function void and put a reference to it to not return anything from the function. And since we are only swapping variables within our matrix, we don't need to create any additional memory, and we don't need to create any variables, and we don't need to return anything if you use void function. Alright, so let's continue. How can we do this? So first we need to take the transpose of a matrix. So remember, transpose will be I will go through 1 to n, and j will go through I to n, or I plus 1 through n, whichever you prefer. Let's use this one since it's a little bit optimal. So I'm writing the for loops now. I started by 0, I smaller by met.size and I plus plus, and j starts from I plus 1, j smaller than met.size and j plus plus, and we are going to swap matrix ij with matrix ji. However, remember this, since we are using a square matrix, I've written that j smaller than met.size. However, if it was a rectangular matrix, remember to put I here. Otherwise, you'll just only scan rows, and if rows are greater than your column size, you'll get a signal error. Alright, so Alright, so now we've successfully have the transpose of matrix. So if you remember what I said, now we need to swap the left half of the variables with the right half now. So how are we going to do this? It's actually pretty simple again. Scan all rows, scan all columns divided by 2. So we are going to have two nested for loops again. For I started by smaller than met.size and I plus plus. This is the trick here. Now, j will scan all the rows divided by 2 and j plus plus. And since this is a square matrix, we are simply omitting the middle line here because we don't need to swap the middle line with anything. Therefore, this condition is perfectly appropriate. So now we need to swap our variables. So I'm going to swap arrays ith and jth element. Oh, I'm sorry, matrix. I'm not sure why I'm writing array. So what will be the syntax in here? So now we are iterating through j smaller than matrix.size divided by 2. So what do we need to do? We need to subtract matrix.size from our jth element, minus 1. Why minus 1? Since our matrix size is greater than our last index size, we need to subtract 1 of it. So it will go like this. We are going to subtract minus 1 from matrix.size as well as our jth element. So this code snippet here, this will swap left half of matrix with right half. Actually, this is it, so let's try to run it now. I'm not calling the function first. As you can see, we have a simple normal matrix, and I'm just going to call the function before printing our matrix now. So what was the name of it? Rotate image, and I'm doing matrix to it. I'm sorry, v here. Let's try to run it now. As you can see, we have the same solution as code signal wanted. So this is how to how to rotate a matrix, rotate matrix without using any additional memory. Only used when square matrices. Therefore, this is it, guys. I hope you liked my video. So see you guys in the next interview tutorial. Take care, guys.